Hello again, ladies and gentlemen, and welcome to another video. We are on section 8.1. I promise that all of chapter 8 will not be flipped, but I thought this was a good way to start off because we've already spoken about the Pythagorean theorem, and the goals in this video and tomorrow in class is that we'll be able to use what we call the converse, and classify triangles. So those are our goals for this section. I think we probably already have in our notes previously, but the Pythagorean theorem says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So in our right triangle, we have the legs A and leg B. I always tell kids, you guys are probably more advanced with this, but they make the L for legs, and the hypotenuse is the longest side. And the theorem says a squared plus b squared equals c squared. C is always your hypotenuse or the longest side. There are some common Pythagorean, what we call triples, that I would take the time to know. 3, 4, 5. So when you have a triangle and the legs are 3 and 4, the hypotenuse is going to be 5. Your hypotenuse, again, is always the longest side. 5, 12, 13, 18, 15, 17, and 27, 24, 25. These are good multiples to know. You'll see them show up a lot, even on SATs. And if you know these and you know that, oh, I could take that triple and multiply everything by 3 and come up with 9, 12, 15, it'll make things a lot easier because you won't always have to use the Pythagorean theorem if you notice these triples showing up in some problems. So for our first problem, we're going to find the value of x, and x is the hypotenuse, so I'm actually going to call it c. And once we do that, we're going to decide if this is a Pythagorean triple. So I'm going to put it into a squared plus b squared equals c squared. I'll call this side a and this side b. Doesn't really matter which one's which. So we have 5 squared plus 12 squared, and that's supposed to be equal to c squared. 25 plus 144 is equal to c squared, and we're getting 169 equals c squared. When I want c, I'm going to take the square root of 169, and that comes out to 13. So this is indeed a triple. 5, 12, 13 is a triple. Basically, a triple is any time you're using Pythagorean theorem and your two legs and your hypotenuse are integers. A lot of times when we try to use Pythagorean theorem, we get decimals and we have to do rounding. The converse, the Pythagorean theorem, basically says, again, converse, we're kind of inverting our hypothesis and conclusion. It says if the square of the length of the longest side, so our c squared, a squared, and b squared, is equal to the sum of the squares of the other lengths, of the other two sides, then it is a right triangle. So in other words, when you set something up and you put in 3 squared plus 4 squared, ask yourself, does it equal 5 squared? So we get 9 plus 16 equals 25. 25 equals 25. Because these three numbers work in the Pythagorean theorem, it means that those 3 side lengths, in this case 3, 4, and 5, are actually making a right triangle. So we can decide if this is a right triangle. The question is this a right angle here? This would be the longest side. Try to call this A and B and C. If 8 squared plus 7 squared would be equal to the square root of 113 squared, if it is indeed equal to that, then this must be a right triangle. So we get 64 plus 49 equals 113. And when we add that up, we get 113 equals 113. So our answer is yes, it is a right triangle. But sometimes when you have a situation like this, you're going to get something that might not be equal. And that can give us some interesting information as well. These are the inequalities. And when you put numbers into the Pythagorean theorem and you get that c squared is less than a squared plus b squared, that's going to tell you we have an acute triangle, that c is not a right angle, it's actually smaller than 90. And if you put a squared and b squared and put it into and equal c squared, and you don't get that they're equal, but you get that c squared is actually greater than, so this angle right here is actually bigger than 90, it tells us we have an obtuse triangle. So in this next question, it says verify that segments with lengths 4.3, 5.2, and 6.1 feet form a triangle, and would it be right, acute, or obtuse? Well, the first thing we all have to realize, and I've mentioned it before, is the longest side always has to be your hypotenuse if we have a right triangle. So when I set this up, I'm going to call this A, this B, and C would have to be the longest side. So I plug the three numbers into the Pythagorean theorem, and this is what I'm testing. And I'm actually going to put like a question mark over the equal sign, because when you work this out, and yes, calculators are helpful, please don't try to do this, it'll take you forever. I get 18.49 plus 27.04, and that gives me 45.53. And 6.1 squared is 37.21. So here we see that c squared is actually less than a squared plus b squared, which tells me it must be an acute triangle. So I hope you've written down these examples. We'll work through more problems with the Pythagorean theorem tomorrow in class. Have a good night.